Hi everybody, this is Gigi Durant from Kauai Community College. Today we are learning about right triangle trigonometry, and I am recording outdoor today, so you might hear birds chirping, the wind blowing, or nature sounds. Okay, so hope you enjoy. All right, so trigonometric ratios. These ratios are ways that we tie an angle to the size of a right triangle. In Pythagorean theorem, we only talk about the size of a right triangle, right? So in trigonometry, we are talking about the ratio of the size and how that relate to the angle. Okay, so suppose we have a right triangle ABC here. The side that is opposite to the right angle C, we call that the hypotenuse, not the hippopotamus, but I think that's a good visual for you to remember, right? And suppose we are going to focus on this angle X right here. We call the side across from X opposite. We call the side next to X adjacent. And we define the following ratios. Sine of the angle X, we read that as sine of X, is opposite over hypotenuse. In this case, it would be A over C. A over C. But I don't want you to remember A over C. I want you to remember opposite over the hypotenuse, depending on where the angle is, right? And cosine is adjacent over hypotenuse. Again, in this case, it would be B over C, but we're not going to remember that. We want to just say adjacent over hypotenuse, and tangent is opposite over adjacent. In this case, it would be A over B, but we, again, not gonna remember that. We would say just opposite over adjacent for tangent. All right, so let's do a specific example given some length in a right triangle. Okay, so we have a right triangle there. This angle is called alpha, and this angle alpha, and this angle right here we call theta. Okay, those are Greek letters that we normally use to denote angles. All right, so we are going to focus on the angle alpha. Okay, sine of the angle alpha, sine is opposite over hypotenuse. In this case, opposite would be 5, and hypotenuse would be 13. So we are saying sine of alpha is the ratio of 5 over 13, and it's a fraction, or if you punch this into your calculator, you get a decimal. So that's just what sine of an angle is, a ratio or a fraction, okay? And then cosine of alpha, cosine, we define that as adjacent over hypotenuse. So in this case, it would be 12 over 13. 12 over 13, which is almost 1, right? Because 13 over 13 is 1. And then tangent of alpha is opposite over adjacent. In this case, it would be 5 over 12. 5 over 12, which is almost a half, because 6 out of 12 is a half, right? Okay, so that's what the definitions are of those three trig ratios. Now I want you to pause and wonder about this question that I am posing to you. True or false? Sine of alpha is the same as sine of theta. Okay, so what do you think? Are they the same or not? If you say no, you are right, because sine of alpha, which would be opposite of alpha, and that would be 5 over hypotenuse, and that is 13, right? But sine of theta, theta is right here. So sine of theta is 12, which is opposite, over hypotenuse, 12 over 13. So no, they are not the same. Okay, good going there. All right, now the next thing I want to practice with you, did you hear that chicken? Yep, that's from my yard. The next thing I want you to be able to practice is calculator use. So grab a calculator, pause the video if you need to, and find these buttons on your calculator. You may have to change your calculator into degrees first. So find that button to make that happen and just type it in and write it down. Round your answer to 2 decimal places. Okay. Pause and do that. Now, once you have done that, did you get 0.68, 0.36, and 0.71? All right, good job. Now we know how to use our calculator to find sine, cosine, and tangent of an angle, given how many degrees the angle is. Okay. What we want to do next is to take a look at this example here. Solve the triangle. What does that mean? That means to find the measurement of all the parts of a triangle, meaning find all the angles and find all the lengths. Okay. So first, let's find the missing length. Okay, now this is a right triangle. So we know Pythagoras would say leg 1 square plus leg 2 square equals to the hypotenuse square, right? So we would have 3 square plus 4 square, not 4 square. We don't know that. I know that, but that's what we're looking for. So 3 square plus right here, let's call that x. X squared is equal to 5 squared. And then when you solve for it, you know that x is 4. Okay, so that missing length is 4, because this would be 9. That's 25. 25 minus 9 is 16. And what square give you 16? That is a nice positive number for a length. That would be 4. All right, so we have done that. Now find tangent of theta. Now that we have all the sides, tangent of theta is, again, tangent is opposite over adjacent by definition. And let's go take a look at theta. Theta is right here. That angle is right here, right? So opposite would be 3 and adjacent would be next to it, and that is 4. So then this is 3 over 4, or we would say 0.75. Okay, I like using fraction rather than a decimal, but hey, sometimes the answer doesn't come out nice and you have to use a decimal. Find the angle theta and the angle alpha. Now, how do we undo tangent, right? So from problem number 2, we say tangent of theta is 3/4. Okay, so how do we undo tangent? Because we know when you're solving, the process of solving is to undo the operation, right? So how do we undo tangent of some angle? Okay, so look at your calculator and look at the second function of the button tangent. You will see this right here. That's not to the exponent -1. That's actually read as the inverse tangent. Okay, so that would be, how do we undo tangent? We do inverse tangent. And that is tangent with the little exponent on top, but it's not an exponent. It denotes inverse tangent of 3/4 or 0.75 if you like to type in a decimal instead. Okay, so once you do that on your calculator, I'm gonna grab my calculator and type that in. How many degrees is that? 0.75 inverse tangent. So I have theta being approximately 36.87. 36.87 degrees. Is that what you have? Okay. Now, once you find theta, how do you find alpha? Okay, so remember that in a triangle, the sum of all the angle is 180, right? So we have a right angle, that's 90. And then we have the 36.87. So 180 minus 90 minus 36.87. We have alpha being 53.13 degrees. Good job there. Now we have found all the parts of the triangle, and that's what it means to solve the triangle. Okay, the next definition in application of trigonometry that you need to know is angle of elevation and angle of depression. So we measure the angle of elevation or angle of depression based on this horizontal line right here where your eyesight is, right? So the angle that is formed from the horizontal up to where you're looking, that's called the angle of elevation, or down is called angle of depression. Okay, now let's take a look at an example of how you will use trigonometry to solve problems. Okay, suppose you let out 100 feet of string while flying a kite. Looking at the kite, you measure or approximate the angle of elevation to be 50 degrees. The question is, how high is the kite? How high up is the kite? Okay, so round your answer to the nearest foot. And you want to pause and start with drawing a picture of what's happening. All right, so once you have drawn the picture and take a look, does your picture look something like this? Okay, so the string is 100 feet and the angle of elevation is 50. That's right here. That angle there is 50. And we are looking for how high the kite is. And we can see that there's a floating right triangle here up in the air, right? We are looking for x. So in relation to the 50-degree angle, x is opposite, and we have hypotenuse, opposite hypotenuse, that calls for sine. So we would say sine of 50 degrees is x divided by 100. to solve for x is to undo the operations around it. So we would say, hey, we're going to multiply both sides by 100. So x is equal to 100 multiplied by sine of 50 degrees. Punch that into your calculator. You have approximately 76.6, being this length right here, 76.6. The unit is feet. Okay, so how high up is the kite? Well, the height of the kite is 76.6 feet plus whatever your height is, right? Because you're standing right here. That's you right there. All right, so that is it for today. We will see you next time.